This video is about sinusoidal modeling. That's modeling a scenario using a sine function or a cosine function. This is AP Precalculus topic 3.7. If you appreciate this content, please give it a like. Number 1. The graph of the sinusoidal function h is shown in the figure above. The function h can be written as h of theta is equal to a times the sine of b theta plus d. Find the values of the constants a, b, and d. Actually, the complete model would look like this, with a plus c in this position. The fact that there is no plus c means that c is equal to 0, meaning that there is no phase shift. The lack of a phase shift means that one period starts right here at 0. The fact that this period of h of theta is upside down compared to the parent function y equals sine theta, which looks like this, means that the a value is going to be a negative number. Specifically, the a value will be the opposite of the amplitude. The amplitude is the distance from the midline to the maximum value. In this case, the amplitude is 2, so the a value will be negative 2. We have memorized that the b value is given by 2 pi divided by the period. In this case, the period starts at 0 and ends at pi, so the period is pi. Therefore, the b value will be 2 pi divided by pi. The pi's cancel out, leaving a b value of 2, which goes right here. That just leaves the d value, which corresponds to the midline. Since the midline is at y equals 1, then the d value is positive 1. So a is equal to negative 2, b is equal to positive 2, c is 0, and d is 1. Let's do the same thing for number 2. Again, the lack of a c value tells us that c is equal to 0 and there will be no phase shift. The lack of a phase shift means that one period of the function starts right at 0. So here I've traced over the first period of the function. Notice that this is oriented the same way as the parent function y equals cosine theta. Therefore, the a value will be a positive number. Specifically, the a value will equal the amplitude, which is 3. We have learned that the b value is given by 2 pi divided by the period. One period of function f starts at 0 and ends at 4. So the period is 4. Therefore, the b value will be given by 2 pi divided by 4. 2 over 4 is the same as 1/2. So this expression reduces to pi over 2. So b is pi over 2. Finally, the d value corresponds to the midline. Since the midline is at y equals 1, the value of d is positive 1. In summary, a is 3, b is pi over 2, c is 0, and d is 1. Number 3. The figure shows the graph of a sinusoidal function h. What are the values of the period and amplitude of h? I have traced over the first period of h. It starts at 0 and ends at pi over 2, so the period is pi over 2. We can tell that the midline is here at y equals 1, halfway between the highs and lows. The amplitude is the distance between the midline and the highest value. 4 minus 1 is 3, so the amplitude is 3. This corresponds to an answer of C. Number 4. The figure shows the graph of a sinusoidal function h. What are the values of the period and the amplitude? I have traced over one period of h, which starts at 0 and ends at 2 pi. So the period is 2 pi. The amplitude is the distance between the midline and the highest value. So in this case, the amplitude is 3. Therefore, the answer is C. Number 5. The figure shows the graph of a sinusoidal function f. Write an equation for f. I'm going to write two slightly different equations for the graph of f. My first equation will be based on the first period of f, which starts right here at 0. This period of f looks like the parent function for cosine x, except it is upside down. So I will use cosine to model f, but the fact that this period is upside down compared to the parent function means that the a value will be a negative number. Specifically, the a value will be the opposite of the amplitude. In this case, the amplitude is 3, so the a value will be negative 3. We know that the b value is given by 2 pi divided by the period. This period begins at 0 and ends at pi over 2. So the period of f is pi over 2. When you divide by a fraction, you multiply by the reciprocal. So b will equal 2 pi times 2 over pi. The pi's will cancel each other out because I have one high and one low. That will leave 2 times 2, so b is equal to 4, which goes right here. Because this period starts right at 0, there is no phase shift, and the value of c is 0. So normally I would put plus the, I would put the opposite of the phase shift, but it is 0, so I don't really need to put anything right here. And then finally, the d value corresponds to the midline. Since the midline is at y equals 1, I will put a plus 1 on the end. So this is one equation for f of x. I can write another equation for f of x based on the period of f that looks identical to the parent function y equals cosine x. Because this period is right side up compared to the parent function, the a value will be positive. So instead of negative 3, it will be a positive 3. The period did not change. So the b value won't change, so the b value is still going to be 4. Another thing that did change is the c value. The c value was 0 when I was looking at a period that started right at 0. This period begins at an x value of pi over 4. This is the phase shift. The c value is the opposite of the phase shift. So the c value will be negative pi over 4. And that's what goes right here. The d value still corresponds to the midline, which has not changed. So that's still going to be positive 1. So here are two different possible equations for the graph of f of x. Number 6. The figure shows the graph of a sinusoidal function g. Write an equation for g. Always start by drawing the midline halfway between the highs and the lows. The parent function y equals sine x looks like this. If I look at the one period of g that we're given that starts right at 0, it looks just like this parent function. So I'm going to use a sine function to model g, and since this is right side up compared to the parent function, the a value will be a positive number. Specifically, the a value will equal the amplitude, which is 2. We know that the b value is given by 2 pi divided by the period. In this case, the period starts at 0 and ends at pi, so the period is pi. The pi's cancel each other out, giving us a b value of 2, which goes right here. Normally, we would find the c value now, which is the opposite of the phase shift. But this period starts right at 0. So there is no phase shift, meaning that the c value is 0. So you can either put a plus 0 in here, or you could just leave it blank. That just leaves the d value, which corresponds to the midline. The midline is at y equals -2, so let's put a -2 on the end. And that's it for number 6. Number 7, the function f is given by f of x equals -2 times cosine of pi over 4x minus 1. Which of the following could be the graph of f of x? Notice that there is no c value, so there is no phase shift. The lack of a phase shift means that one period of the function will start right at 0, like this, or like this. We have memorized that the parent function y equals cosine x looks like this. Because f of x has a negative a value, it means that f of x should be upside down compared to the parent function. So we are going to look for the first period to be upside down like a is. And it should not be right side up compared to the parent function the way b is. So we can throw out options that look like b. We will throw out the ones that look like the parent function. So again, looking at c and d, the correct answer will be an upside down cosine function. So we are going to throw out d, which is a right side up cosine function. Notice that f of x has a b value of pi over 4. We can use this to help us choose between option A and option C. So take option C for example. Let's calculate the b value based on the graph. We know that the b value will equal 2 pi divided by the period. This period begins at 0 and ends at pi over 4. So the period is pi over 4. When you divide by a fraction, you multiply by the reciprocal. So b will be given by 2 pi times 4 over pi. The pi's will cancel out because we have one high and one low. That will give us b is equal to 2 times 4, or b is equal to 8. This is not the correct b value, so the answer is not C. Okay, b is not 8, it should be pi over 4. So the correct answer must be A, but of course we shall follow through and see why this gives a b value of pi over 4. We can calculate the horizontal distance from peak to peak to find the period of option A. From -4 to +4, that's a period of 8. And then we know that the b value will equal 2 pi divided by this period. 2 over 8 reduces down to 1/4. So this simplifies to a b value of pi over 4, which is correct. So the answer is A. Number 8. The figure shows the graph of a trigonometric function g. Which of the following could be an expression for g of x? Focus on option A for a moment. We see that there is no c value. In other words, c is equal to 0. There's no phase shift. That means the first period of function A would start right at 0. But the first period of function g looks like this. Is it possible that this period matches function A? We have memorized that the parent function y equals sine x looks like this, while the parent function y equals cosine x looks like this. Option A is a sine function, but this first period of g matches the cosine function, so the answer cannot be A. Now focus on option B. Option B has a c value of -pi over 2. That means we're looking at a phase shift of +pi over 2. So one period of option B is going to start right here at +pi over 2. So I'm going to go ahead and trace one period that starts at pi over 2. Again, this period looks like the cosine function, not a sine function. So the answer cannot be B. Now focus on option C. Option C has a C value of negative pi over 4. That means a phase shift of positive pi over 4. So, therefore, one period of the function will start right here at positive pi over 4, and I'm going to trace one period of function g starting at pi over 4 and see if we have a match. This does look like a cosine function. However, this would be an upside down cosine function compared to the parent function. That would mean that the option would have to have a negative a value to be correct. And since option C has a positive a value, then this is not a match. The correct answer must be D by the process of elimination, but let's follow through and see why D makes sense. The C value is negative 3 pi over 4. Therefore, the phase shift is positive 3 pi over 4. That means that one period of this function will start at positive 3 pi over 4. So I'm going to trace one period of function g starting at, well, that wasn't great. Starting at 3 pi over 4, and then I'm going to look to see if we have a match. Well, this period of function g would be a cosine function, and this is a cosine function, but this is an upside down cosine function compared to the parent function. So we are expecting to see a negative a value, and that is exactly what we do see. So it makes sense that the answer is D. Let's do the same thing for number 9. Focusing on option A is immediately out. We see the D value of positive 2, meaning that the midline would be y equals positive 2. This is not the midline. Alright, the midline is indeed y equals negative 2, which we see on all of the other options. So A is out. Now focus on option B. We see a C value of negative pi over 2. Therefore, the phase shift of option B is positive pi over 2. That means one period of this function will start at positive pi over 2. If we trace out one period of function f starting at positive pi over 2, then now we can look and see if we have a match. So this looks like an upside down sine function. So we do have a sine function. However, the a value is positive. So we were looking for a right side up sine function that had this orientation. So B is not the answer. Focus your eyes on option C. C is an upside down sine function. So option C is going to have this type of shape to it. Option C has a C value of negative 3 pi over 2. Therefore, it has a phase shift of positive 3 pi over 2. So one period of option C will begin at 3 pi over 2. So if I begin to trace function g starting at positive 3 pi over 2, and I'm sort of reaching the end of the graph, so I'm just going to continue the pattern, it would look like this. Notice that this pattern is a match for what we expected. It's an upside down sine function. So the answer is going to be C. But let's follow through and see why D is not the answer. Option D is another upside down sine function. So we are expecting one period of option D to have this shape to it. The C value is negative 2 pi, so the phase shift of option D is positive 2 pi. So one period of option D will begin right here at 2 pi. So if I trace out one period of function f, and I'm going to have to just continue the pattern. Okay, the rest of the pattern would go like this. This is the look of an upside down cosine function, not an upside down sine function. So that's why option D is wrong. Let's do the same thing again for number 10. We can tell that the midline is right here, halfway between the highs and the lows. This midline matches the D value of options B, C, and D. It does not match option A. So right away we know that A is not the answer. Option B is a right side up cosine function. So we will expect one period of option B to have this shape to it. We notice that the C value is negative pi over 2. Therefore the phase shift is positive pi over 2. So one period of option B will begin right here. So let's trace out one period of graph H and see if it matches our expectations. And it does. This period looks just like what we were expecting. So the answer is going to be B. I'm going to swiftly run through the other options and show you why they do not match our expectations. Option C is a right side up sine function. So we are expecting one period of option C to look like this. The C value is negative pi over 2. So the phase shift is positive pi over 2. So one period of option C would start here. If we trace out one period starting at pi over 2, it's going to look like this. This is a right side up cosine function, not a sine function. So skirt. Option D is an upside down sine function. So we are expecting the first period of option D to look like this. The C value of option D is negative pi. So the phase shift is positive pi. That means that one period of option D will start right here at pi. If I trace out one period of function H starting at pi, it's going to look like this. This is an upside down cosine function, not an upside down sine function. So that's why D is not the answer. Let's do the same thing for number 11, starting with option A. Option A is a right side up sine function. So we will expect the first period of option A to look like this. Option A has no phase shift. The C value is 0. So that means one period is going to start right at 0. So if I trace out one period of K starting right at 0, that's going to look like this. This is an upside down sine function. We were looking for a right side up sine function. That's why A is not the answer. Option B is an upside down sine function. So we are expecting one period of option B to look like this. Option B has a C value of 0, so no phase shift. So again, we are starting right at 0. And if I trace out one period of graph K starting at 0, it looks like this. This is a match. An upside down sine function is exactly what we were looking for. So the answer is going to be B, but let's keep going. So looking at option C, we are expecting a right side up sine function. So we are expecting one period to look like this. We notice that the C value is negative 2. So therefore the phase shift is positive 2. So one period of option C will start at positive 2. So if I trace out one period of K, that would look like this. This is a right side up sine function. Wait a minute, that's a match. Okay, I was too hasty when I just automatically said that B would be the answer. It may still turn out to be the answer, but we have options B and C are both matching our expectations so far. So we cannot eliminate either one of these options yet. So let's look at option D before we come back to the showdown between B and C. So looking at option D, this is an upside down cosine function. So we are expecting the first period of option D to look like this. The C value of option D is positive 1. So the phase shift is negative 1. So that means one period of option D is going to begin right here at negative 1. If I trace out a period of the graph of K starting at negative 1, it's going to look like this. This is a right side up cosine function, and we were looking for an upside down cosine function. So D is not the answer. To choose between options B and C, we can use the B value because these have two different B values. So let's calculate the B value based on the graph and see which one is a match. We have memorized that the B value is given by 2 pi divided by the period. So B will equal 2 pi divided by. Now, what's the period? We can measure the period as the horizontal distance from peak to peak. From negative 1 to positive 3, that's 4. So the period is 4. 2 pi over 4 reduces to pi over 2. And that is the B value of option C. So the correct answer is C. Number 12. The graph of H and its dashed midline for 2 full cycles is shown. 5 points F, G, J, K, and P are labeled on the graph. No scale is indicated and no axes are presented. The coordinates of the 5 points F, G, J, K, and P are as given here. The function h can be written in the form h of t is equal to a times the sine of b times t plus c plus d. Find the values of the constants a, b, c, and d. I'm going to write my equation based on this period of function h, which looks like a right side up sine function when compared to the parent function. So the a value will simply be the amplitude, and we know that the amplitude will be the highest value minus the middle value. So 12 minus 9 is 3, so the a value is 3. Now it's time for the b value, which we know to be 2 pi divided by the period. I'm going to switch gears a little bit and calculate the period from peak to peak instead of using this red period that I have highlighted. From F to P, we're going from an input value of 0 to an input value of 20. So that's going to give me the period of 20 immediately, 20 minus 0. So the period is 20. So B is 2 pi divided by 20, which simplifies down to pi over 10. So that's the B value, which goes right here. Next, the C value. The C value is the opposite of the phase shift, and the phase shift is the first input value of the period that you're focusing on. Notice that my input values go from 0 to 5 to 10 to 15 to 20. You can easily see that the input values are increasing by 5 each time as I go to the right. Or, if I go to the left, the input values are decreasing by 5 each time. So this first input value at this orange point will then be negative 5. So this is the point negative 5, comma 9, borrowing the output value from the other points on the midline. Anyway, the negative 5 is the phase shift. So therefore the C value will be the opposite of this phase shift. So the C value will be a positive 5, which goes right here. That leaves only the D value, which corresponds to the midline. Looking at all of these output values of the 3 points that are on the midline, I can see that the midline is y equals 9. So therefore the D value is positive 9. So A is 3, B is pi over 10, C is 5, and D is 9. You can either record your answers separately like this, or you can record your answer like this, an equation for h of t with the values of A, B, C, and D filled in. Number 13 is just like number 12 with new input-output pairs. I'm going to use this period of h to build my sine function. Since this period is right side up compared to the parent function, the A value will be positive. Specifically, it will just be the amplitude, which is the highest value minus the middle value. So 6 minus negative 1 is 7. So that's the amplitude, and the A value is 7. Next, it's time to find the B value. But in order to find the B value, we first need the period. We can calculate the period by finding the horizontal distance between peaks. So from peak to peak, the input values go from pi over 2 to 3 pi over 2. So the period is going to be 3 pi over 2 minus pi over 2. 3 pi over 2 minus 1 pi over 2 is 2 pi over 2. The 2's cancel out, and we find that the period is pi. We know that the B value is always 2 pi divided by the period. So in this case, 2 pi divided by pi. The pi's cancel out, leaving a B value of 2. The C value is the opposite of the phase shift. And the phase shift is going to be the first input value of the period that we're using to build the function. So what is this input value? I'm going to think of all of my input values as having a denominator of 4 so I can compare them easily. I already have the 5 pi over 4 and the 3 pi over 4. So let's think of this pi as 4 pi over 4. Pi over 2 can be thought of as 2 pi over 4. So we are going from 5 pi over 4 to 4 pi over 4 to 3 pi over 4 to 2 pi over 4. The next input value to the left would be 1 pi over 4, or simply pi over 4. I might as well record the output value of negative 1, which is the midline value. So my phase shift is positive pi over 4. Therefore, the C value will be the opposite of this, which is negative pi over 4. That just leaves the D value, which does correspond to the midline. The midline is here at y equals negative 1. So the D value is negative 1. And that's it for number 13. You can either record your answer like this or leave it like this. Number 14 is the same thing with new input-output pairs, and it's cosine this time. We need to build a cosine function, and we have memorized that the parent function y equals cosine t looks like this. I'm going to use this period of h to write my cosine function because it looks just like the parent function. That way, the A value will simply be the amplitude, which is the highest value minus the middle value. 40 minus 30 is 10, so the A value is 10. In order to find the B value, we first must determine the period. From peak to peak, the input values go from pi to 5 pi. So the period will be 5 pi minus pi. Therefore, the period is 4 pi. we know that the b value will be given by 2 pi divided by the period. So in this case, that's 2 pi divided by 4 pi. The pi's cancel out, and 2 over 4 reduces to 1/2. So that's the value of b. The c value is the opposite of the phase shift, and this period begins at an input value of pi. So pi is the phase shift, therefore the c value will be negative pi. That just leaves the d value, which corresponds to the midline. Looking at points G and K, I see the output value on the midline is 30. So that's the d value. You can either record your answer like this, or just leave it like this. Number 15 is another cosine model with new input-output pairs. I'm going to build my cosine function using this period of h, which looks identical to the parent function. That way the amplitude will match the a value. The amplitude is always the maximum value minus the middle value. 12 minus 7 is 5, so that's the amplitude and the a value. To find the b value, I first must find the period. From peak to peak, the input values go from 0 to 1 over 25. So that means the period is simply 1 over 25. The b value is always going to be 2 pi divided by the period. So in this case, that's 2 pi divided by 1 over 25. When you divide by a fraction, you multiply by the reciprocal. So b is going to equal 2 pi times 25. Therefore, b is going to equal 50 pi. The c value is the opposite of the phase shift, and the phase shift is the first input value of the period that you are using. The first input value is 0, so that means the c value is also 0, which we don't really have to write, but I can just put a plus 0, or I could have left it blank. That just leaves the d value, which corresponds to the midline. And looking at these output values for the points that are on the midline, I see that the midline is at y equals 7. So the d value is positive 7. Easy peasy. And that's it for number 15. You can either record your answer like this, or leave it like this. Hey guys, don't forget to like and subscribe. But also, if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.